Welcome to Smart Architectural Programming. Mastering list intersections in Python.
My name is Mohammed, and coding alongside me
is George, and today we'll be going over mastering list intersections in Python. I'll let you take over, Mohammed.
so on a scale of of importance of list intersections in the concepts need to know as a programmer. It's somewhere in between. It's not overly important, but it's not at the same time something that you can ignore if you want to become a professional programmer. Because on a large extent, a lot of people explore this topic about list intersections on social media, on YouTube, on Google for that matter. So it is something that might come up in your professional careers as programmers. So it is something that that is beneficial for you to at least know what it is, right? So what is list intersection? So when we talk about what list intersections are if you have two or more lists that you need to work with, and you need to find unique but common elements between those lists. That is all what list intersection is. So if we have two lists, as you can see on lines 2 and 3 on the code that I've opened up on my screen. Um, what I mean by common elements is that between these two lists, one list having elements of 1, 2, 3, 4, 5, and the other list having elements of 3, 4, 5, 6, 7, have common elements of 3, 4, 5. So if we do list intersection, the result should be uh, 3, 4, 5. That's all list intersection is. It's finding and identifying common elements between two or more lists and saving them in some manner. So on line 5, you'll notice is where our first method among the 4 different methods that we'll go over in this video about how you can do list intersection. But we'll start with one of the most easiest and simplest method. That is which implementation is done on line 5. So here we in the variable called intersection result, we convert the list 1 to a set, and then the converted set is on the converted set we apply the method called dot intersection with the input being list2, and that is how you should be able to get common elements between these two lists. And then on another variable on line 6 we can convert intersection results back to a list. Now a lot of you might be questioning, why are we converting uh, a list to a set before doing a conversion operation on this? And you'll find out as we go further in this video, this is not a unique thing that I'll do just for this case. It was pretty much standard on most of the methods that we'll go over later. And there's a very simple reason for that. There's a very simple reason as to why I would potentially convert a list into a set before doing intersections. Because and keep in mind, this is a fairly common approach in Python, and because it serves a specific purpose, rather two specific purposes that I'll go over. Sets in Python are unordered collections of unique elements, which means keyword here being unique. So in most cases, when you're doing list intersections, you'll also need to make sure that you have only unique elements. By unique element, I mean, like in the previous case, you have 3, 4, 5 as common elements. But if you have 2 3s in a list, you don't want 2 3s to be there in the final output of the intersection. So set make it show so that you are not able to have duplicates within the final output, and the duplicates are removed when you convert a list to a set. And that's basically what sets mean. You have sets saying that they have unordered but unique elements within them. But another very important reason, I think this is probably even more important than duplicate elements, because you may or may not need to include duplicate elements. That's completely up to you. But in most cases, you would prefer removing the duplicate elements in an intersection. But the second reason is very important. It's probably the primary reason that most people use sets, convert lists to sets before intersections, and that's because uh, finding intersections using sets improves the efficiency of the intersection operation. So let me clarify that in a simple way. So if we have the timing for an element, if we convert it to if you look at line 10, the line 11 that I just posted, so you see the O convention is basically a convention used to depict the upper limit of the program time. And the upper limit of a program time may not seem relevant to you, but it is when you're dealing with large complex programmers, because it does not just tell you how much time it takes for a program to be completed, but it tells you how much resources a computer would be using to conduct that program. So our O convention, which shows that the upper limit of a program, it tells us that the minimum time, if we use the set method, the minimum of the length of those two uh, of the lengths of the two lists is probably going to be the upper limit of time that we're going to take. So if we have 5 elements in the two lists, so the upper limit of these two lists converted to sets would be the time for this operation to complete. That should be 10 10 seconds, give or take, right? But at the same time, the second element, if we do not convert a list to a list to a set before doing a list intersection operation, you'll notice the time exponentially jumps up. So it means it takes more time and it takes more resources if you do not convert a list to a set before doing an intersection operation. And if you look at the OMIN operation on line 12, that shows exactly that. So if we do it based on a list, so we'll have the minimum time, a minimum upper time. The upper time would be the minimum of length of list 1. That's 5. That's the same as first, but the list 2 aspect goes to list 2 into list 1. So that would be 5 seconds plus 5 into 5, 25 seconds. So it exponentially jumps up the time that you need to conduct an intersection operation. And that is why moving forward, you'll see in most of the operations, I'm converting lists to sets before I'm doing the intersection operations.